Hello friend, welcome you all. Today I am going to show you that how you can make or create setup for your ELISA plate reader if you are using Gen5 software along with Biotech ELISA plate reader instrument. Today basically I am going to show you procedure setup, plate setup, data analysis setup, data export with an example of ELISA plate experiment having the standard, sample and blank. So let's start. Here you can see I am using the Gen5 version 3.13, and if you open the software, by default task manager window is open, and in the task manager you can see the read, experiment, protocol, instrument, control, and at the right side you can see the new. If you click here, this will open to make a new experiment, and here you can also open your existing protocol. But maybe in your case you are not able to see the task manager. Like if I click here and the close, now you can open the task manager by clicking here. Just click here, you can see the same window is open here, and at the top here is the menu and the toolbar. And I'm not going to show you about the window layout and toolbar because I have already prepared a tutorial about this, and in which I have discussed in detail each and every component of this software. So you can go through that tutorial. I am providing the link in the description and get more information from there. So now here you can see in the task manager left side, read now, experiment, protocol. So if you click here on the new, so at the left side in the layout you can see the file explorer, and protocol is open, and in the protocol you can see there are 4 steps: procedure, plate layout, data reduction, and report export builder along with one plate. Protocol along with plate consider as experiment, that is save as .xpt file, and protocol without plate and its format generally .prt. So I have already prepared a tutorial about protocol and the experiment regarding Gen5 software. So I am providing also the link for this. You can go through it. You will get the more information about the protocol and the experiment. What are the differences between these two? But today I'm not going to discuss all these things here. I'm just going to show you how you can set up your protocol for your experiment of ELISA plate reader. So here you can see the protocol showing the star, means the protocol is not saved. You can see the name here, experiment 1, and here is the window that is open for the procedure. At the left side these are the steps, and first you can see here the plate type. You can see here 96 well plate, but if you click here on this window you can see there are lots of options for the plate. You can select according to your experiment, and please be sure before selecting the plate, and this is dependent on the plate reader instrument that you have, because each instrument doesn't have the capability to take the reading for all type of the plate. So please be make sure that your instrument is compatible with your plate. So I'm going to select the 96 well plate because I have 96 well plate for my experiment, and here use lead. So if you are using the lead you can check, otherwise you can uncheck this box. And the second option you can see here, the select wells per step and at the runtime. Per step means it will not ask you to select the well during the acquisition of the absorbance or the data. But if you click here on the runtime, and when you will keep the plate on the machine, this will ask you to select the well, which well you want to use for the absorbance. So I'm not going to select the at runtime, I'm going to select the per step. At the left side, you can see the read. First step, read. Just click here on the read. You can see the new window is open, and step level you can change your name. And at the right side, you can see the full plate because we have the per step. So if you click here on the full plate, you can see, as I said, that if you select the per step, this will not ask you during the acquisition to select the well because it is already selected for all the well. This will take the absorbance from all the well, and you can assign the well from here. Like I'm not going to use all the well for the experiment, so I will select this well and click here. So during the acquisition, this will take the absorbance only from these wells, but I'm going to select all the well. And the next is detection method. If you click here, so Biotech ELISA plate reader comes with the absorbance, fluorescence, and chemiluminescence. So according to your machine type and your experiment that is compatible with your machine, select your detection method. So in my case, it is absorbance. So I'm going to select the absorbance, but in your case, select the type that you have for your experiment. And the read type, here you can see in point, area scan, and spectrum. So in my case it is in point, and the read speed normal, you can select according to your experiment. And here is a path length correction. Path length correction is used to compensate for variation in the path length of light as it passes through the sample in a microplate well. In absorbance spectroscopy, the amount of light absorbed by a sample is directly proportional to the concentration of the absorbing substance and the path length of the light through the sample. So you can understand, if your ELISA plate, each well have the different level of the liquid or the amount of the that you are going to use for your observance, that will affect your whole data. But if you have the similar, all the equal amount of the volume in all the well, so you don't need to check this path length correction. And if you click here, if you want to know more, just you can see the more information about it, but I'm not going to check it because in my case my all the well have the equal amount of the sample, so I'm not going to check this. At the last, in the read step, you can see the wavelength. In my case it is 562. It is not showing here, but you can manually enter here. But maybe in your case you have to take more than one wavelength. You can click here and select the wavelength that you want to use to take the absorbance for your plate. But in my case I have only one wavelength, so I'm selecting this. Click here on OK to complete the read step. Here you can see it is showing 562 nanometer for the read step, and you can select all the parameter that required according to your ELISA type. Like if you want to set the temperature of the machine, like here you can see incubator on 37 degrees centigrade. I don't require this, so I'm not going to check this. And the shake, if you need shake for your plate, you can set up your shake step here. And here you can see there are options: slow, medium, fast, variable. So you can see, you can select according to your experiment. Dispense, in some ELISA type, if you need the dispensing in your experiment, you can use this option, and you can select the volume and dispenser to do this. And if you are using the kinetic ELISA, you can just click here on the start kinetic, and you can set up your kinetic ELISA experiment, like the runtime, what runtime you need, and what the interval and the reads do you need. You can set up here. Like this, you can select all the method according to your experiment. But in my case, absorbance ELISA, I don't need all these things, so I'm going to click here on the OK. Here you can see you are not able to see the any plate, and if you click here on the plate and select the view option, click here, now you can see plate is showing here. That's why I was discussing that if you don't know about the layout, please visit my previous tutorial about the Gen 5 layout, so that you can get the information about everything, so that you don't need to worry about anything regarding the view of this Gen 5 software. So as we set up the procedure step of the protocol, the next step is plate layout. If you click here, you can see the plate layout wizard is open. But this is optional. Here I suggest you can take the reading after setting the procedure, because as you know that it will take the absorbance from whole plate. So you can set up all these things after taking the absorbance, and you can make changes about the plate layout, data reduction, and export. So I suggest you, if you are using multiple plate to for your experiment, select the procedure, set procedure, and take the absorbance for all the plate, and later on just go for each plate and set up the layout, data reduction, export, and get your data. But I'm going to show you how you can set up the ELISA plate layout. So if you click here the plate layout, you can see the plate layout wizard. So in my case I have blank, standard, and the sample in my ELISA plate. But if you have the assay controls like negative, positive calibrators, you can click also the assay control option and the sample control as well. But I have only three things in my plate. Just click here on the next. Now you can see the blank option, plate layout ID, BLK. This is short form, and you can see the full name here, blank. If you want to keep full name, you can type here. And replicate, I have in the replicate to replicate. So also you can change the text color and the background, but I'm not going to change all these things. Click here on the next. So now you can see the standard curve. So by default the ID is STD. like it will be 1 2 3 like this short form, and you can keep the full name here by typing here. So this is also I have in duplicate. At the lower side you can see the concentration. So I can show you first my plate layout, what the sample and the standard I have. Here you can see my plate layout. So I have BCA protein estimation assay, and in which I have the standard 812 in duplicate with the value 16 microgram to 0.125 microgram with half dilution, and 3 sample in the duplicate and the blank. So this is the layout that I'm going to set up here. So I have 8 standard starting with the, you can see the concentration or dilution here starting with the 16 microgram. And if you want to keep the unit, you can type the unit here, microgram per ml. And here at the right side, if you see the increment factor and ratio, increment means if you click here and insert any value, and if you just click here, this will just increase the value that you put here for the increment. So this is not in my case. So I have half dilution. So I'm just clear the list. So in my case, I have half dilution in my all the same standard. For this, I'm going to click here on the factor, and for the half dilution, just put the 0.5 and click here on the well wells. So you can see it is automatically put the value. Click here on the next. Now the sample SPL, and here on and the replicate you can see, and you can put here, you can see the dilutions. If you have dilution in your sample, you can assign here, but if you don't have, don't need to put any value here, and you can use these to assign dilutions in your sample, but I don't have, so I'm going to click here on the finish. Now you can see this open a new plate layout wizard or window where you can assign your sample standard and blank where you have in your plate. So you can select anything here first, but you don't need to follow the hierarchy. Just like you can select the standard first or blank. So I'm selecting the blank here, and here is the option serial assignment replicate. So I have two replicate, so I'm going to just drag here. You can see blank is assigned. For standard, I'm going to click here on the first standard, and here you can see replicate 2, and the by default it is checked the next concentration. So you will jump automatically on the next concentration when you will assign the standard in the well. And here it is very important to know how the option works. In the replicate, you can see it is showing that your standard replicates are in one column and arranged vertically, but this is not case. So my standard are horizontally arranged in column 1 and column 2. So if you click here on this icon, now you can see it is showing that standard is arranged in column 1 and column 2, and each row have the replicate for each standard. So this is very important to assign here, and then select the standard and just drag on all the concentration. Now you can see your all the standard is assigned. But anyhow, if you want to delete any standard in the well, just click here on the empty, and now select the well that you want to make empty. Again, if you want to keep the value that was already present here, select that value and again assign here. So in this way you can assign your standard and blank as well as sample. For the sample, select the sample here. So I have 3 samples, so I'm going to just select these 3 wells in the duplicate. Now click here on the OK. You can see here the absorbance that we have set up for like 562, and if you click here on this arrow, you can see the layout that we have assigned for this plate. And the next step is data reduction. As I earlier discussed that We can take the absorbance after setting the procedure. We don't need to do all these things. We can perform all these things after taking the absorbance. But I am showing here just for the tutorial purpose. So I'm going to click here on the data reduction. This is the step where you make the setup to calculate your absorbance and your data. So you can see the data reduction step. Here is showing the transformation for the blank that we have assigned here. You can see here it subtract automatically from the absorbance. Like you can see the data in 562 nanometer absorbance and blank well. When you take the absorbance from your plate, this will subtract automatically from your data. You can see x minus blank. As I discussed that in my experiment, I have a standard curve. So I'm going to click here on the curve, but you can select according to your experiment type and the data analysis. So click here on the curve. You can see the standard curve. You can change the name, and first step is data in, and the data in generate curve from the current plate. So you can see the well ID standard, and x axis, that is concentration that we have assigned for this standard, and the y axis, that will be our absorbance value corresponding to the standard concentration. And the next, if you click here on the curve fit, there are many options for the curve fit. By default it is selected on the regression, and in the linear regression you can see formula y is equal to a star x plus b. And if you want to change the curve fit according to your experiment, you can change. And in the non-linear you can see 4 parameter, 5 parameter and other. So there are many options. You can change or you can select according to your requirement. And here is the option for the extrapolation factor and the parameter constraint. So if you want to change according to your requirement, you can change. And the next option is the data out. This is the option to calculate the concentration. Here you can see if you have interpolation, any you want to make any interpolation, you can create here. So I'm not going to do anything here. So click here on the OK. Now you can see in the data reduction option, standard curve analysis is added. And when you will take the absorbance, this will automatically calculate your concentration on the basis of the absorbance. I'm going to click here on the OK. So the last option in the protocol is report export builder, and I will show you after taking the absorbance about this, so you can change according to your requirement. So the plate option here in this experiment, this plate 1 is added, and if you want to add more plate, just click here on the plate and add plate here. So you can put the number of plate that you want, and you can add the plate here. If you click here on the plus button, you can see the information associated with particular plate. And here I want to show you that protocol is set for the this experiment, and like if you have the second plate and the sample standard location is different, like in the second plate, you can take the option and you can create the custom plate layout for this plate. So, and I can assign the location of sample and standard in my plate too, but I'm not going to show you. But in your case, if you have, you can do that. I'm going to delete the plate 2. So after setting the experiment protocol for the experiment, you can take the absorbance now. Like if you click here, read now. After setting the protocol, click here on the read now. So it is showing that the specified compound does not exist. So I'm just showing to set up the experiment here in my system. My system is not connected with the machine. So I'm going to show you separately how we take the absorbance using the ELISA plate reader machine. So I'm going to close this. Here I am showing an experiment in which we have the HRPTMB ELISA type, and we are adding the stop solution. This is not the same experiment that I am showing the data for the analysis purpose. After adding the stop solution, we just keep the plate on the carrier of the biotech plate reader machine, and here you can see read in progress. And after reading this, automatically open the window to save the experiment.xpt and the Excel file. Here you can see the data that I have acquired or recorded from the plate reader machine using the setup that I have shown in my tutorial. So you can see at the matrix, it's showing the observance at 562 nanometer. And if you change the value blank subtracted, you can see the blank subtracted observance and the concentration. You can see it automatically calculated the concentration of the sample. So I forget to add one sample. There was one more sample here. And if you click here, so here you can see the statics of this experiment. Well ID, name, well, concentration, dilution, blank, concentration, and other things like mean, standard deviation, and the coefficient of variation. And if you click here on the graph, you can see the graph of the standard curve, concentration was versus the absorbance value, blank subtracted absorbance value, and the formula value, and the like as I earlier said that you can change the analysis. Like if I click the data reduction again here, and if you want to change the curve fit, like here, take the option, click here and edit, and you can change the curve fit like 4 parameter and click OK. So you can see our curve, standard curve is changed according to our parameters. So it is optional. You can change your analysis after taking the observance, and this will change your data according to your requirement. So this is very easy to do this. Now for the report, if you click here on the report, you can see all your data is exported in the Excel file, and you can see all the information, plate layout, and the results with the all the absorbance value. You can see the here 562 blank subtracted, and also the concentration for all sample that we have assigned here, and the standard curve and the value. And if you want to change the export or report, just click here. Here you can see, if you click here, there is the option to change or modify the report that you can set up here, like matrix or row wise, column wise. If you want to change, you can change according to your data type requirement. I'm going to just click here again. If you want to export, now you can see the representation of the result is changed by changing the type of report. So in this way, you can make setup for your experiment in your Gen 5 software, and you can use your analysis very easily. And if you have any problem, let me know. I will help you as much as possible. And thank you for watching my video. If you like the video, please subscribe my channel. Thank you.